Lecture number 13 in this series is related to adaptive delta modulation. It will cover CLO1 and it is present in section 6.4 of your textbook. The contents which we will be covering today are discussing ADM transmitter and its advantages. As we have seen in delta modulation that due to quantization errors we have to face slope overload distortion and granular noise, and it is because of the reason that the step size is fixed in delta modulation. To overcome this problem, adaptive delta modulation was proposed. In adaptive delta modulation, to overcome quantization errors which we have to face because of slope overload distortion and granular noise, step size is made adaptive. So it is the most important part, that here step size is not fixed but it is adaptive in nature. If the input signal is slowly varying, then delta is reduced or its size is decreased, and if signal is changing rapidly, then delta is increased or its size is increased. Thus such method is known as adaptive delta modulation, because here the step size is adaptive. Slope overload causes several pulses of same polarity in succession. As you have seen previously, that due to slope overload we are getting same polarity in succession. This calls for increase in step size. So if we face such condition, then we have to increase the step size. Similarly, for granular noise, polarity of the pulses altering continuously means sometimes it is plus minus. So it is showing that the polarity of the pulses is changing continuously, and it indicates small amplitude variations. Thus it requires a reduction in step size. So here is the ATM transmitter. The lower part is similar to delta modulation, and the only block which we have added here is the logic, and this logic will decide whether the step size should be increased or it should be decreased. So this logic is involved here, and on the basis of this the remaining transmitter will work. The advantage which we can get because of ADM is that it has better signal to noise ratio than delta modulation because of less distortions or less quantization error. Thank you. This is all for this lecture.